Welcome today. I want to take you through this important practical paper, Practical Chemistry Paper 3. I want to let you know that Chemistry, Biology and Physics Paper 3 is going to be your savior in sciences. The paper in paper 3 carries 50% of the subject. So if you do more practice in paper 3s, you are going to score more in your final exam in sciences. So I want to take you through this paper, a very important paper, so that we can go. You are provided with 0.3 grams solid A, solid A, which is magnesium, and hydrochloric acid solution B, 0.5 sodium carbonate solution C. This one was supposed to be 0.5 molar solution C, methyl orange. So there is a letter that is missing here. This one is 0.5, 0.15 capital M solution C, and a methyl orange indicator. You are required to determine the enthalpy change per mole of the reaction between magnesium, metal, and excess hydrochloric acid. So remember, metal with hydrochloric acid, that reaction is a metal plus, which is going to give us salt plus a gas is going to be produced. And then if concentration in moles per liter of hydrochloric acid, solution B. Procedure. It is important for you to understand the procedure, what is happening in the procedure. Using a burette, measure 50 of solution B, and remember our solution B is HCl. Solution B is HCl. If you doubt, you go back and check. Place it in a 100 plastic beaker. Measure the temperature of solution B in the beaker after every 30 seconds and record it in the table. At the 90 second, add all the solid A provided into the beaker. Start with the thermometer and continue measuring the temperature and recording the temperature after every 30 seconds. Complete the table. So this table here from 0, remember it is the solution yenye umeweka ndani ya beaker 50 centimeters cube. So there is nothing you have added. So the temperature will be the room temperature. So in most cases, the room temperature, it depends to where you are. We will have 22 or 23, it depends, or 25, it depends. So in this case, we want to use 22.0. Because there's nothing you have added, it will remain 22.0. It will be a constant. 22.0. Always for temperature, record with 1 decimal place. So immediately it reaches 90, that is 30 seconds, 60, and then 1 minute, 30 seconds, that is 90 seconds. You add the solid A, magnesium. And then from there, the temperature will rise. So it rose, it can end up 43.0, it can end up 47.5, it can end up 48.5, and then ikaanza kushuka 47.5, 46, 40, that is to 10 is 47.0, 47.0 to 40 is 46.7, 46.5, and then 46.0. Record temperature using 1 decimal place. Plot a graph of temperature against time on the grid provided. So we are going to draw a graph of temperature against time. So remember to label the graph. So we are going to label the graph as you can see here. This is our graph of temperature against time. So nimeweka hizo points 22 ndio hii 22 22 22 22 as you can see, and then I have put the points there. So this is a graph of temperature against time. Na ukiangalia here we are doing energy changes. Energy changes, mtu mwingine anaweza fikiria ati sasa hapa anafaa kuchora curve. Unafaa kujua what are you dealing with. If you are dealing with energy changes, there is no day you are going to draw a curve for energy changes. No. Energy changes, there is no day you are going to draw a curve. So here, we are going to draw a straight line here. And then draw a straight. Take these points, uweke ruler, uangalie zile points zinachukua the maximum number of points, and then you draw a straight line. Ikishafika the last point hapa, you extrapolate the value, the line into to our reference point, which is 90. This X here remains, it is our reference point. X hii tuliweka kwa table. This X is our reference point here. Then you draw. So unachukua hizi points, hizi nne za mpande hii, you will draw the point, you will draw using these points, a line here, a line using these 4 points mpaka itafika hapa. So you extrapolate using dots this line to our X. Remember here we have X, that is the reference point. At this point here, this is where we have the maximum temperature. Maximum temperature. Remember that. So in energy changes, we don't have a curve. There's no way you're going to draw curves here. Remember that. So after that, now we are going to use this graph to answer the questions. I have drawn the graph for you. So let us use it to answer this question that is following. Determine the change in temperature for the reaction show. So ukisha extrapolate hapa, mahali hii extrapolation dotted line inafika kwa hii curve, hapa ndio unasoma. So yangu imefika hapa, so unasoma hapa. Unapata kwamba hapa temperature, the highest temperature ingefika ni 50. So hatukufika 50, but the highest temperature ingefika ni 50. So that is the maximum temperature. Remember, temperature change is maximum minus minimum. So temperature change is equal to 50 minus initial, which was 22. I can use the decimal point, 50 minus 22.0, and the answer is going to be 28.0 degrees Celsius. So that is the temperature change. It is final minus initial, and our maximum temperature is 50. Na umeona venye nimepata hiyo 50. Calculate the heat change. The heat change is equal to capital M, mass of the solution, times specific heat capacity, times temperature change. Now, what volume of the solution did we use? We had put into the beaker 50 centimeters cube of solution of solution B. This is what is guiding us. The solution yenye ilitumika, because capital M, when we are calculating heat change, the M, it is the mass of the solution. Kama ni water, ama ni whatever. So now here you use the HCl. What was the mass? the mass was 50, the volume was 50 centimeters cube. But 50 centimeters cube is the same as 50 grams. Why? Because the density is 1. So 1 centimeters cube is equal to 1 gram. What about the 50 centimeters cube? Itakuwa 50 grams. So this is 50 grams. We divide it by 1,000 to change this one into kilograms, and then times specific heat capacity tumepewa 4.2 times temperature change, which is 28. So when you multiply this, you get it is 5.88 kilojoules. Kilojoules, J should be written in capital letters because it is the name of the owner who came up with this energy changes. So that is the heat change. Given that the relative atomic mass of magnesium is 24, calculate the enthalpy change for the reaction per mole. So what we are looking for is molar enthalpy. We are calculating molar enthalpy. Molar enthalpy for 1 mole. So first let us get the moles of magnesium. Moles is equal to mass over RAM. The mass was 0.3 divided by 24, and that one gives us 0.125. 0.00125. Moles. That is the number of moles. So this is the moles that produced 5.88 kilojoules. So we say 0.0125 moles was able to produce 5.88 kilojoules. Now, what about 1 mole? Because molar means for 1 mole, 1. So we will ask 1 mole will produce how much? So it is 1 times 5.88, you divide by 0.0125. This one gives us 470.4 kilojoules per mole. Kilojoules per mole. Before you move on, if you don't write the sign whether the reaction to show that to indicate that the reaction was exothermic or endothermic, you will get negative a half marks. So half is going to be deducted from the equation. Remember, this thing is given one mark. Umefanya mpaka umefika hapa, alafu unanyanganywa hapa mark because hukuweka sign. It is very painful. Umefanya kazi mingi, unapata hapa mark. Kwa hivyo to be careful, remember the reaction, temperature was increasing from 22, 43, 47, 48. So the reaction is exothermic. Whenever the reaction is exothermic, you indicate by writing the negative. Therefore, the final answer should be negative. So the answer should be negative 470 degrees, 470.4 kilojoules per mole, and that is the molar enthalpy. The negative shows that the reaction was exothermic. Procedure 2. Fill a clean burette with 0.15 molar sodium carbonate, solution C. So solution C is sodium carbonate, that is okay, 0.5, 1.5 ml. Place all of this mixture in the beaker, perform procedure this, into volumetric flask. Now you need to understand the mixer yenye tuko nayo from procedure 1 ni mixer ya nini? Tulikuwa na magnesium ika-react na HCl. So hii HCl lazima ilikuwa in excess 50 centimeters, 0.3 iwezi maliza. So the solution that we have here in the beaker yenye tunaweka hapa ndani ni HCl. Ukumbuke hivyo because hii react ikatengeneza magnesium chloride plus hydrogen gas ikahepa, So what we have is a magnesium chloride and excess HCl in the beaker after the reaction. Now we are taking this 50 centimeters, this solution in the beaker yenye tulipakisha from procedure 1 tuiweke kwa volumetric flask. We top up with water and then we label that solution D. So solution D ni nini? Solution D ni HCl. The difference with this one initially, this one is diluted, highly diluted, more diluted. It is more diluted. Hiyo ndio tofauti. Now we have put the remaining solution from procedure 1 in the beaker into a volumetric flask. We have added water to 250 and we have labeled that solution D. Now, pipette 25 of solution D. Remember, solution D is HCl diluted. Remember that. We are adding 2-methyl indicator, and then we have to titrate against using sodium carbonate, which is solution C. Remember now, what we have in the purette is solution C. What we have in the conical flask is dilute HCl, which is solution D. So what's happening here? Solution C, sodium carbonate, solution C, sodium carbonate is going to react with HCl. It is an acid base, it is a carbonate plus an acid. Hiyo ndio nataka na understand. Remember, hii ni C na hii ni D. Kama huwezi elewa hivi, sasa hiyo inakuwa ni shida. You need to understand the way I'm getting it here. So the table, I will give you the code after the titration. Remember to fill the table with 1 decimal place. Always. Initial, always write 0.0. Don't write anything else. 0.0, 0.0. And then put your 23.5. Sorry, this one is 23.8. 23.5 and then 23.5. Now, ukiwa umefanya practical na umepata 23.8, 23.5, 23.5. Ukiangalia hii range 23.8, 23.5 na 23.5, hii ya kwanza iko far away because accuracy inafaa kuwa plus or minus 0.2. Lakini hii ukiangalia imeenda 0.3. Therefore, this is an outlier. The value is outside. Therefore, tukifanya average, tutafanya na hizi mbili peke yake for you to get the accuracy marks. Sawa? Ndio maana nimeweka hapa intentionally ni kuonyeshe kwamba ukipata the value, ukiangalia hii decimal place na hii inaishinda by more than 0.2, then ukumbuke hautaitumia kwa average. Sasa hii itakuwa 23.8, 23.5, 23.5. Nikienda kutafuta average ya solution C, now I will do with 2, 23.5 plus 23.5 divide by 2, kwa sababu nikiweka hii itakuwa an error na sitapata accuracy marks. And this one will be 23.50 centimeters cube. Namna hiyo. So tushapata the volume of sodium carbonate 0.15 molar used ni hiyo. The next question is calculate the number of moles of sodium carbonate used. That is very simple because we have already the number of moles in 1,000. Remember, sodium carbonate tulipewa 0.15 capital M. Capital M implies that moles, that 1 means that 0.15 is the number of moles in where? In 1,000 centimeters cube, in 1 liter. Kumbuka, capital M stands for molarity. It stands for molarity. And the molarity is the number of moles in a liter. In a liter, 1,000 centimeters cube. So whenever you see 0 point something capital M, Capital M stands for molarity, and the molarity is the number of moles in a liter. Sasa hii tulipewa 0.15 moles are contained in 1000 centimeters cube. We will find out ile volume yenye tumetumia sodium carbonate solution C is equal to 23.5. Yeah, it was 23.5 our average. Will be how many moles? Itakuwa how many moles? So you take your calculator, 23.5 times 0.15 divided by 1000. So unapata ni unapata ni 0.00352 moles. So this is the number of moles of sodium carbonate solution C used. Hiyo ndio imetumika ya C. Now the next question is calculate the number of moles of hydrochloric acid in 25 centimeters cube solution D. Now to get that, you must write a balanced equation for the reaction between HCl and the sodium carbonate. That is the only remedy. That is the only thing that will help you. It is to write a balanced equation. So let us write the balanced equation, that is HCl reacting with sodium carbonate, which is going to form the salt sodium chloride plus CO2 plus water. So that is the equation. Then balance the equation, because sodium hapa ni 2, you can put it 2 here and then 2 there. So from here, you don't need to write the status, because here the equation tunataka ikusaidie for balancing the equation only. Now, the number of moles of sodium carbonate tushapata ni 0.00352. And the mole ratio, as you can see, it is 1 to 2. 1 to 2. The mole ratio is 1, here is 1, and here is 2. So it means now moles of solution D is going to be twice this one. So you say, remember we had D to C, and the ratio is 1 to 2. And this one is 0.00352. So you say 1 is equal to this, what about 2? So moles of D will be equal to 2 times 0.00352, and that one is equal to 0.00705 moles. Very nice. So that is the number of moles. Hydrochloric acid, the number of moles of hydrochloric acid in 250. Now we have gotten the number of moles of hydrochloric acid in 25. What about 250? So you say 0.00705 is the number of moles of HCl solution D in 25 centimeters cube. 250 centimeters cube will be equal to what? So it is 250 times 0.00705. You divide by 25. So hiyo inakuwa ni 0.0705 moles. So that one will be 0.0. That is the number of moles of solution D in 250. Solution D. Now calculate the number of moles of the acid that reacted with magnesium metal. Sasa tunatuuliza tu ile magnesium metal yenye react into kianza procedure 1. Na hapa kuna information unafaa kujua. The information you need to know is very important here. Remember, magnesium reacted with HCl in the ratio. So you need to write the equation and check now. So magnesium reacted with HCl to form magnesium chloride plus hydrogen gas. We put it to here. Now we have the number of moles. We have the number of moles of HCl here. We can get the number of moles of magnesium. To know the number of moles of HCl and react, tuko na number of moles of magnesium. Remember, we calculated the moles of this tukapata ni 0.0125. Hii ni number of moles of magnesium yenye react na HCl mwanzo tukianza experiment. So tunataka kujua hii itakuwa ngapi, lakini you can see the ratio magnesium to HCl ratio is 1 to 2 from the balancing. Hii moles zake ni 0.0125. So itakuwa ngapi? Sitakuwa twice. So moles of HCl that reacted with magnesium is equal to 0.0125 times 2. Na hiyo unafinya calculator unapata ni 0.025 moles. This is the moles of HCl yenye react na magnesium initially kabla tukuje kwa procedure 2. Very nice. Now the question asks, calculate the total number of moles of hydrochloric acid in 50. Ile 50 yenye ilikuwa kwa bika, initial moles zake total ilikuwa ngapi? Total yake ilikuwa ngapi? Sasa tushapata moles yenye iko kwa 250. Moles yenye ilikuwa kwa 250 ni yenye ilikuwa imebaki after magnesium imereact na HCl. Na tumepata moles in 250 ndio hii hapa part Roman 3 which is 0.0705. Hiyo ndio moles yenye ilibaki in 250. Sasa tushapata moles in 250 na tumepata moles ya acid yenye react na magnesium. So how do you get the total? Total you just add. So it is 0.025 plus 0.0705. So you just simply add 559.0. So it will be 0.0955 moles. So hiyo ndio moles yenye ilikuwa kwa solution B originally. Very nice. Next thing is to determine the concentration of hydrochloric acid in moles per liter. That is simple. If now we have gotten the number of moles in 250 because tulianza na 250, tuliambiwa put 50 centimeters cube of HCl. So 50 centimeters cube of HCl tumepata moles zake ni 0.0955 moles. Concentration in moles per liter means molarity. Molarity is the number in 1,000. Number of moles in 1,000. Concentration in moles per liter ni moles in 1 liter, and a liter is 1,000 centimeters cube. Now 1,000 centimeters cube is equal to 1 liter. So we will ask 1,000 centimeters cube HCl itakuwa na how many moles? 1000 times 0.0955 divide by 50, na hiyo itakupea itakuwa ni 0.0955 times 2 times 2 times 20 times 20, yeah, because 50 inaenda kwa nini 20 times, ina mara moja hapa mara 20, so the answer is going to be 1.91 capital M. Capital M stands for molarity. Molarity is the number of moles in a liter. Kama utaandika hivyo unaweza andika 1.91 mole per liter. Mole per liter. Very nice. Let me take you through qualitative analysis. You are provided with solid E. You are provided with solid E. Carry out the following test and record the observation in the inferences, the spaces provided. Place about 1/3 of solid E in a dry test tube. Heat the solid strongly. Test any gas with both litmus blue and red litmus paper. So once you put your red and moist litmus paper on the mouth of the test tube, make sure the test tube is very dry. That's one thing you need to do. The test tube should be very dry, should not contain any water or any droplets of water, because you need to make observation whether there is a colorless liquid formed on the cooler parts of the test tube. So that is the first observation, is that a colorless solution liquid condenses on the cooler parts, of the test tube. So ukiangalia hiyo test tube hapo juu utaona imesweat, inamaanisha iko na water of crystallization. So you can simply say hydrated salt. Solid E is hydrated. Or you can simply say hydrated salt. Or you can say it contains water of crystallization. It contains water of crystallization. Contains water of crystallization. Hiyo ni observation ambayo inakuja by the way, lakini the major thing we want to test the gas produced by litmus paper. That's where the main observation is. What happened? Did the litmus paper change to blue or not? Did the blue litmus paper remain blue or change to red? What happened? So you need to tell us. So the observation is that the red litmus changes. Don't write a tan, but write changes to blue, and blue litmus remains blue. So if that is the case, then it means the gas that was produced was a base, so that it can change now red litmus paper to blue. So if it is a basic gas, you can simply write basic gas present. It is allowed. Or you write ammonium ion. Ammonium ion present. color. No, white is not the thing. You write ammonium ion, positive present. Next, place the remaining amount of solid in a pouring tube. Add 15 centimeters of distilled water. Shake. Divide the solution into 4 test tubes, each containing about 2 centimeters cube. So the first portion, add 3 drops of diluted hydrochloric acid. Diluted hydrochloric acid, it depends. It will form a white precipitate, or we expect. And because you are adding HCl, the first thing we expect is effervescence. Whenever you are adding an acid to something, we expect effervescence. So the first thing is that we expect effervescence, but there was no effervescence. No effervescence. So whenever you are adding an acid, the first thing you expect is effervescence. So you check whether effervescence occurs. So if effervescence is not occurring, it means either the carbonate is not there, the sulfite is not there. Is absent. This one is absent. And then another thing we expect is that HCl ikiingia hapo, chloride ikiingia, ikutane na lead, itatengeneza white precipitate, lead chloride. Ikikutana na silver, itakutana na silver, itengeneza silver chloride, which is a white precipitate, silver chloride. But now there was no white precipitate, no white PPT. So if there's no white PPT, it means that lead, silver, H2 positive is absent. So these ones are absent. Next, to the second portion, add 2-3 drops of aqueous barium nitrate. Barium nitrate, we expect a white precipitate because barium will form a white precipitate with a sulfite, carbonate. Now, was there a white precipitate? Let's check. Yes, a white precipitate is formed. White PPT is formed. So a white PPT is formed. Then we expect normally for barium, the sulfite, the carbonate, the sulfite. Hii barium carbonate is a white precipitate. Barium sulfate is a white precipitate. Barium sulfite is a white precipitate. But initially tulisema carbonate na sulfite is absent. So hakuna venye tena utaziweka hapa. Hiyo ndio inaitwa elimination. So remember here in the previous tulisema that kwa sababu ya hii tukasema no effervescence, it means no white precipitate. Kwani hili jilidelete? Sawa. No white precipitate. Therefore, if that is the case, then no, we said here that no effervescence, the sulfite, the carbonate is absent. So usiilete tena hapa. Ukileta hapa utakuwa umecontradict. So this one is just SO4 2 minus present. That is the chemistry we are talking about. To the third portion, add aqueous sodium hydroxide dropwise. There we expect a white precipitate, either soluble in excess or insoluble in excess. There's something we had put here. Sijui kwa nini imepotea hapa, tulisema no white PPT. Na tukasema lead, silver, positive, absent. Absent means it is not there. So you will see now this one information hapa penye itatusaidia mbele kuamua ni nini tunafaa kuandika. Itatusaidia kujua ni nini tutaandika mbele. Next, sasa hapa tukifika hapa, we are adding sodium hydroxide. A white precipitate is formed soluble in excess. White PPT, which dissolves in excess to form a colorless solution. Soluble in excess. So a white precipitate soluble in excess, it means ZAP is present. ZAP stands for zinc, stands for lead, stands for aluminium, and the amphoteric. So if you write zinc 2 present, aluminium 3 present, and then wewe ujui kueliminate umeandika 2 lead, now this one will cancel the whole answer. The lead will cancel the whole answer. This is correct. Lakini initially hapa tulisema kwamba lead hapa no white PPT, kwa hii no white PPT means that lead, silver is absent. So kama tulisema hapa iko absent, how come tena ukirudi hapa, ukikuja hapa utakuja kusema at iko present? Therefore you will go wrong, and that is why you will fail here. Therefore here we will have only zinc. We will have only zinc and aluminium present. Very good. Present. Ukiandika silver hapa, ama ukiandika lead, you get nothing there. You have cancelled the whole mark there. You get 0 kwa inference. To the fourth portion, add aqueous ammonia droplets until in excess. Then what happened? White precipitate is formed insoluble in excess. So white precipitate, white PPT, insoluble, which does not dissolve in excess, insoluble in excess. So if it is insoluble in excess, then it means zinc is absent, because zinc, when you add ammonia solution, zinc dissolves to form a colorless solution. Now it means zinc is absent, and if zinc is absent, then what is present is aluminium. So aluminium, 3 positive present. Zinc is absent, and they discourage negative answers. Zinc 2 is absent. For this one, you tell us what is present. Don't write what is absent, because we know what is present. We use absent where we do not have an option. But here we have option that the aluminium is present. Therefore, it is not encouraged to use the negative answer when we have the positive answer. So the cation present is aluminium. You are provided with solid F. Carry out the following test and record the observations and inferences in the spaces provided. Place solid one-third of solid F in a clean metallic spatula and burn it, burns a burner flame. So we expected the solid to burn because this is organic. How do you know this one is organic? When you read number 3, you will see we have the reagents that will guide us. We have acidified potassium permanganate. We have bromine. Now bromine will confirm that we are dealing with organic analysis. Organic analysis. So this one is organic. We expect you to write the double bond, triple bond, those things. So here we don't have cations and anions. Not at all. So did the solid melt? Did it burn? Yes. With which flame? Blue or yellow? CO2. So this one, solid F, melts and burns with yellow sooty flame. Yellow sooty flame, then it means unsaturated organic compound present. It is allowed for you to write unsaturated organic compound present. It is allowed, but if you want to write this one, unsaturated ni gani? Ni mbili, ni double bond. Make sure the carbons are 4 covalent bonds or triple bond. The carbon should have 4 covalent bonds surrounding it. So these ones are present. Tumesema unaweza tumia hii jibu ya juu ya maneno unsaturated organic compound present, or you write this one present. Place the remaining amount of solid F in this in a boiling tube. Add water. Shake. Sasa we want you to tell us whether did the solid F dissolve in water to form a colorless solution? Yes. If yes, then you know what to tell us. Then the solid dissolved to form a colorless solution. Solid F dissolve to form a colorless solution. If that is the case, then it means that the compound solid F is polar. But polar meaning it is soluble in water. Polar means soluble in water. So if it is not, if it will not solve, then it is non-polar. Using 2 decimal, add test for determine the pH using a universal indicator paper and the chart. So you will take the solution. You after adding the universal indicator, check against the pH scale the color, and then look at the pH. So then, for example, this one the pH was equal to 2. pH 1, 2, 3 is a strongly acidic. pH 4, 5, 6 weakly acidic. pH 7 neutral. pH 8, 9, 10 weakly basic. pH 11, 12, 13 is strongly basic. For this one is strongly acidic. Strongly acidic. We are adding acidified potassium permanganate. The color for this one is purple. We expect it to be decolorized. If it is decolorized, then the double bond, triple bond, and the alcohol is present. If it is not decolorized, then the 3 are absent. They are absent. So purple, acidified potassium permanganate, potassium manganate changes to colorless or is decolorized. Changes to colorless. Or simply you can say acidified potassium permanganate is decolorized. So to decolorize means the color changes from purple to colorless. This word means that way. So if that is the case, then the double bond, the triple bond, and the alcohol is present. Those 3 are present. Now, this one is used to test for these three, but for the sake of elimination method, we had said here that these are unsaturated. Na ili burn with a yellow sooty flame. We know alcohols that burn with blue non-sooty flame. Now, if you come here and write, of course, the ROH will change the potassium permanganate purple to colorless. It will change, it will do so. Lakini kumbuka from the beginning pale tulisema haikukuwa because alcohols will burn with a yellow, blue, with a blue non-sooty flame. Now when you put it here, you contradict, and you are going to score nothing. Here, any price itakuwa 0. Therefore, please remember that is the chemistry we are learning. You are not going to include ROH here. The answer is going to be the double bond and the triple bond only. I don't know why my wrapper is not greeting this thing. Tafadhali, I hope umenielewa, na kama hujaelewa contact yangu iko over there kwa site kwa YouTube, so you can just contact when you have a question. This one is present. The reason why nimetoa alcohol despite the fact kwamba acidified potassium permanganate inatumika kutest for alcohol is because here F will burn with yellow sooty flame. Alcohols do not burn with yellow sooty flame. Therefore, if you include it here, it means you don't understand, you cram this content. But for understanding, you need to understand now, if it wasn't there in the first place, I cannot include in the second one. In the next subsequent test, I cannot include it. To the next portion, add 2 drops of bromine. So bromine, we expect the color to change from yellow to colorless, or we say it is decolorized. So bromine water, the color is yellow. You should know that. So bromine water, bromine water is decolorized. To decolorize means the color has changed from yellow to colorless. If that is the case, then it confirms that the double bond or the triple bond confirmed. Now we confirm that this is ndio zilikuwa because tushasema tumedoubt ndio zilikuwa present. Now we have confirmed that these ones are present because bromine inatumika tu kutest for these two. Thank you. Remember to share and subscribe as well. Share, subscribe,